Let's look at this problem. Replace elements in an array. So we are given a zero-indexed array called numbers that consists of n distinct positive integers. So we apply m operations to this array. So where the s operation, we replace the number, the first element in the operations I with the second element in operations I. So here are some assumptions. So this guaranteed that in the S operation, the first element exists in numbers, so that we can replace that, right? And the second is that the operations I, the second element, does not exist in the numbers. So this actually is for consistency. So the problem requires to return the array obtained after applying all the operations. So for this problem, so we here we can look at one example and analyze the way to solve it. So overall, we are going to track the indices. In other words, we want to just make sure we are able to know the number corresponding to each index. So this way actually gives us a hint that we can use dictionary. So here let's look at the first example. So we are given numbers, which is 1, 2, 6, 1, 2, 4, 6, and the operations is given by 1, 3, and 4, 7, 6, 1. So in plain English, so we are easy to understand this one. So the first one is 1, 3. It means that we replace the number 1 by 3 in nums in the array. So after this operation, so the nums change to have a state that is, so the index for 1 is 0. So we change the value corresponding to this index by 3. So others remain fixed. So this is after the first operation. And after the second operation, 4, 7, which means we replace 4. This is corresponding to the index 2 in the numbers. We replace the element corresponding to index 2 by 7. So after this, so the numbers actually correspond to 3, 2, 7, and 6. Right. So then the third one is 6 and 1. So in other words, we replace the number 6 by 1. In the number 6 corresponding to index 3 in numbers. So the numbers after this operation actually comes 3, 2, 7, 1. So which is the output in example 1. So here, the thing to notice is that in the process, actually, what we implicitly used is the index. So basically, the idea is that we, let me write here. The idea is to track the value corresponding to each index. So this way, after the operations, we just examine the value corresponding to each index so that we can get the output. So in this demonstration or example, so we actually implicitly using the indices. So with that said, actually we easily come up a solution by using the dictionary data structure. So first, let me initialize a dictionary. So for this, because I would like to replace, and I want to maintain the indices, but I need to be easily replacing the values. So I will use the values in the number as the key of the dictionary. So this is valid because the reason said that the numbers contains distinct positive integers. That's the use of this assumption. So with that said, let me do something like this. We will use the value as the key and the indices as the value for the dictionary. So for I, Y in enumerate nouns. So with this, then we just need to linearly traversal the operations to just do the replacement. So it's a simple for loop. So for before, after, right? So in operations, so we want to replace before by after. So for this specific operation, so first so after this replacement, we know that the index I, let's see, the index I corresponding to before will correspond to the key after, right? So in translate this into English, it means that, let's see, we first check the index corresponding to before. That's why also a reason we use the number as the key, right? So then after this replacement, because we have replaced this number before, we need to delete this key. So this is an essential step. So we will delete before after we fetching the corresponding ID. Then we just do the resetment. So reset, we just set after corresponding to this index. So yeah, so after this, basically what we get is that we know we correspond to each value as the corresponding indices. Then we will just want to reverse the process so that we can get the output, the desired output. So for this, let's do in a step-by-step way, just not to write it too compact. So let's call the reverse. So basically, I will use it as a list of tuples. So here v k, right? So for k v in the atoms. So this way, the v will correspond to indices. Right? Then I just need to sort and then check the second element to return. Right? So then we'll return. So atom, the second atom for for atom in the reverse. So here I just come back and then because we want to sort it. Let's sort it in place. So if we like, actually we can specify the key. So for lambda, so x 0. In other words, we sort the list of the reverse corresponding to the indices. Then we just then after this sort, we return the list corresponding to the second element in each of the tuple in the reverse. That's the solution for this problem. Let's check for a special case. So here, let me comment out this. So let's check a special case. It passes. And let's check for the generic case. Yeah, that's it. So for your convenience, this is the full code. So actually, you can change the format of writing to make it even shorter. But for better readability, we just keep the representation like this. Thank you.